Hi, I'm Dustin Schroeder. I'm an associate professor in electrical engineering and in geophysics here at Stanford. I'm a radioglaciologist, which means I use radar to study ice sheets both here on Earth, like Greenland and Antarctica, and the icy moons that surround other planets, like Europa, the moon of Jupiter. And the tool we use to do this is ice-penetrating radar. So these are radars like you might use to observe airplanes or look at the surface of the Earth, but we shoot radar waves down through the ice sheet and measure what's happening underneath it and inside of it. The reason my group spans both geophysics and electrical engineering is that the scientists in my group use tools, including things from electrical engineering like electromagnetics and wave propagation and signal processing, to study the Earth and other planets. And the engineers in my group invent new sensors that can measure the ice sheets and answer these questions. It's a really fun space to work in because unlike other areas of radar where there may be commercial applications and the technology is more mature, students, undergrads, grad students, postdocs in my lab are inventing totally new types of radar systems that are the state of the art in how we can observe and understand ice both on Earth and other planets. A couple of projects we're working on right now. I have a PhD student in my group who's building a fixed-wing drone, so a drone that's not a helicopter but has wings and looks like an airplane, that has an ice-penetrating radar built into the wings. And there are challenges with this, like making the radar small enough, like making sure the wings don't interfere with how the radar performs, making the radar powerful enough that it can see inside and beneath the ice sheet. But once we do that, that gives us a lot of capacity we didn't have before. Normally, in order to collect data in Antarctica or Greenland, people need to go and camp on the ice sheet or stay in permanent bases and fly large airplanes that take lots of fuel. These drones can be taken with a field team and launched by hand, can do surveys that measure the ice sheet over and over again, seeing how it changes. They can also make measurements that allow us to see how the ice is flowing by looking at layers inside the ice sheet and seeing how the ice flows. And that gives us understanding of the physics of the ice and helps us have better models that predict sea level rise in a changing climate. 3 words I would use to describe electrical engineering is creativity. I think the engineering drive for me is the drive to invent and create. I guess the other 2 words I'd use are sort of more typical electrical engineering words of signals and systems that helps us understand how we make measurements of the world and interpret those measurements we have. And if you're interested in learning more about the sort of research we do or the courses I teach, take a look at our research group website. I think my favorite spot on campus is actually our group's lab. We have a really fun group of students that includes a lot of undergrads and a mix of grad students and postdocs. I think one of the things that's fun about field science and instrument engineering is it's a team sport. I think hanging out with a group of people trying to solve hard technical and scientific problems is the most fun I can have in the Bay Area.